My name is Prithvisha Nath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. So this is week 12 for this course. So let's start solving some problems. So the first question is, the motion resulting from the change in orientation of the axis of angular velocity vector is called. So there are four options: translational motion, general motion, rotational motion and precision motion. So which option is correct? It is precision motion, right? So that will be precision motion. So moving on to the next problem. A planar wheel is pivoted at O on a hinge which is fixed to the floor and is rotating in the anti-clockwise direction as shown. The wheel can be said to be undergoing fixed point rotation about point O. So is this true or false? The wheel is not undergoing fixed point rotation, right? So this is false. So this is false. Now, moving on to the next problem. Moving on to the next problem, select the correct statement. So this is false. Select the correct statement. Finite rotations are vectors but infinitesimal rotations are not. Second option is both finite and infinitesimal rotations are vectors. And third option is infinitesimal rotations are vectors but finite rotations are not. And the final option is neither finite nor infinitesimal rotations are vectors. So which option is correct? The third option is correct. That is infinitesimal rotations are vector but finite rotations are not. Now moving on to the next problem. The tube QPR rotates with a constant angular speed omega 2 about the shaft SR, which in turn is rotating with constant angular speed omega 1 in the directions shown. Answer the following questions for the given instant based on the given data. Omega 2 is given as 1.5 and omega 1 is 2. So it is said that the tube QPR is rotating with angular speed omega 2 about the shaft, and the shaft itself is rotating with an angular velocity of omega 1. Now what are the questions that we need to answer? What is the magnitude of absolute instantaneous angular velocity? So what is the magnitude of absolute instantaneous velocity? So how can we find out omega? Omega is nothing but omega 1 plus omega 2. Now what is omega 1? Omega 1 is 2i, right? And omega 2 is minus 1.5 j. So therefore omega can be written as 2i minus 1.5 j. Now what we have to do, we need to find the magnitude of absolute instantaneous angular velocity. For doing that, we just compute the magnitude of omega. So that becomes radian per second. So this is the answer. Now for the next part of the problem, what is asked, what is the magnitude of absolute instantaneous angular acceleration of the tube QPR in radian per second square? So we need to find the magnitude of absolute instantaneous So we need to find out the magnitude of absolute instantaneous angular acceleration. So alpha can be written as this. Now we know that this is minus 1.5 j cross 2I. Then what is the magnitude? The magnitude is nothing but 3 only. So the magnitude of instantaneous angular acceleration of the tube is radian per second square. Now what is, they have asked the x component of v. Now for finding out the x component of v, first we need to find out the position vector. So what is the position vector? It can be seen from this figure. It is nothing but 0I 1.2 j and 0.8 k. So R is nothing but 0I plus 1.2 j plus 0.8 k. V equals to omega cross R. Then what we need to do is just find out the cross product. This is 2 minus 1.5 0 0 1.2 0.8. So you just have to calculate the cross product now. I minus 1.5 into 0.8 I minus j, that is 2 into 0.8 plus k, 2 into 1.2. So that is nothing but minus 1.2 I minus 1.6 j plus 2.4 k. So here they have asked us to calculate find out the x component. So it's clearly seen that the x component is minus 1.2, y component is minus 1.6, and the z component is 2.4. So the x component of velocity v is minus 1.2 and the y component is nothing but minus 1.6. And the z component of v is nothing but 2.4. Now moving on to the next problem. A crane operating at site constantly rotates at 1 radian per second about its vertical as shown. The boom of the crane supporting a weight is being lowered with angular velocity and angular acceleration as shown. Considering the positive coordinate directions as shown, answer the following questions for the instant depicted. So what are the questions that we need to solve? They have asked us to find out the magnitude of the instantaneous angular velocity of the boom in radian per second. So what is omega? Omega is nothing but this should be minus 1 j cap minus 0.5 k cap. So magnitude of omega will be nothing but square root of 1 square plus 0.5 square. That is 1.12 radian per second. Now what is the next question? What is the magnitude of instantaneous angular acceleration of the boom? Now first we need to find out alpha 1, that is minus 1j cross minus 0.5 k. So this is nothing but 0.5 I. Now there is another acceleration, that is this beta double dot, right, 0.2. So the total acceleration would be the instantaneous acceleration of the boom in boom is alpha, that is 0.5 I plus 0j minus 0.2 k. Therefore, what is the magnitude? It's nothing but square root of 0.5 square plus 0.2 square. So the magnitude of the instantaneous angular acceleration of the boom is 0.54 radian per second square. So this is the magnitude of acceleration. Now what they have asked is, let represent the absolute instantaneous velocity of the tip of the boom in meter per second. So they have asked us to find out the x component of Vp. So for finding out Vp, first we need to know the position vector of the point P. Thereafter we can find out omega cross r to find Vp. So first we have to know the position vector. The position vector of P is r, let it be r. So from the figure we can see that the x component is 25 cos of 65 degree and the y component is 25 sine 65 degree. So r is 25 cos 65 I plus 25 sine 65 j plus 0 k. Now to find out the instantaneous velocity, now we know omega, we know r, so we can calculate Vp. So let's write this: 0I minus 1j minus 0.5k cross 25 cos of 65 I plus 25 65 j plus 0 k. Therefore Vp will be I j k. Write it in the next page. So this will be (0.5) into 25 sine of 65 degree 0.5 25 cos 65 degree 25 cos 65 degree. So I just need to simplify this now. This is 11.33. The next one is (5.28) J, and the last term is 10.56 K. So what we need to find is the x, y and z components. So from here we can see what are the x and z and y components. So the x component is 11.33. The y component is minus 5.28 and the z component is 10.56, right? Now what we need to do is the next problem, the next part of the problem, what they have asked is let AP represent the absolute instantaneous acceleration of the tip P, and they have asked for the x component of AP, the y component of AP and the z component of AP. So to find out AP, we just need to use the formula, that is AP equal to alpha cross R plus omega cross V. So AP is alpha we already know, R we know, omega we know, and V also we know. So we know all the quantities, we just need to substitute here. 0.5 I plus 0J minus of 0.2 K into that is cross, not into, cross of alpha cross R, 25 cos 65 I, 25 sin 65J, and this is plus 0K plus omega V, omega cross V. Omega is 0I minus 1J minus 0.5 K cross 11.33 I minus 5.28 J plus 10.56 K. So what I'll do is I'll just solve this separately, like alpha cross R separately and then omega cross V separately, and then add these two quantities together. So that will be easier. So let this be 1 and let this part be 2. So first I will solve part 1. I J K 0.5 0 minus 0.2 25 cos 65 25 sin 65 and 0. So we just need to solve this. So I is 0.2 into 25 sin 65 0.2 into 25 cos 65 plus K 0.5 into 25 sin 65. Now just we have to simplify this. That is nothing but 4.53 I minus 2.11j plus 11.33k, and then I'll solve this part, that is part 2. This is 0 minus 1 minus 0.5, and that is 11.33 minus 5.28 and last is 10.56. Solving this, so minus 10.56, again minus, so that is 2.64 0.5 into 11.33 this is also 11.33k. Yeah, k is already written. So this becomes minus 13.2 I minus 0.5 so this is 5.66 J plus 11.33k. Now what we need to do is just add these two, 1 and 2. Now adding 1 and 2. So first is 4.53 minus 13.2. Minus 2.11 plus 5.66, and the last one is 2, the same, so 2 into 11.33k. So this becomes minus 8.67I minus 7.77J, and the last one is 22.66K. So therefore we need to write the x component, y component and z component. So I'm writing the x component. The x component of AP is, you can see that it is minus 8.67, and the y component is nothing but minus 7.77, and the z component is 22.66. So the y component of AP is minus 7.77, and the z component of AP is 22.66. Now, okay, so this problem is over. Now moving on to the next problem. A cannon barrel rotates with an angular velocity omega 2 of magnitude 1.5 radian per second while placed on a platform which is rotating with an angular velocity omega 1 which is equal to 3.5 radians per second, and angular acceleration is omega 1 dot, that is 0.5 radian per second square. A cannonball is fired at a distance of and it is at a distance of r equal to 3 meter at that instant depicted. Further, it is known that at this instant r dot and r double dot is 150 meter per second and 25 meter per second square respectively, measured relative to the barrel. Now these quantities, that is r dot and r double dot, are measured measured relative to the barrel. Answer the following questions for the instant when theta equal to 40 degree. Now this is the figure. As you can see, omega 1, the platform is rotating with an angular velocity of omega 1, and this cannon barrel is rotating with omega 2, and this distance is r, as you can see from the picture. So what is the first question? Let omega represent the absolute instantaneous angular velocity of the cannon barrel in radian second. What is the x component of omega, the y component of omega, and the z component of omega? So omega can be written as, therefore the absolute instantaneous angular velocity of the cannon barrel is this is omega. So we can see it is omega is in the negative y, omega 1 is in the negative y direction, so that is minus 3.5 j, and omega 2 is in the, again it is in the negative x direction, so that is minus 1.5 I minus 3.5 j, that's omega. So now we have to find out, and there is no z component, so that is 0k. So the x component of omega, minus 1.5, the y component of omega is minus 3.5, and the z component of omega is nothing but 0. As you can see, there is no z component in this omega. So these are the problems that we solved for this week. So the first problem was the motion resulting from the change in orientation of the axis of angular velocity is called precession motion. The second problem was a planar wheel is pivoted at O on a hinge which is fixed to a floor and is rotating in the anticlockwise direction. So they have asked whether the wheel can be said to be undergoing a fixed point rotation. So it's not a fixed point rotation. So this is false. And next, what we need to find is select the correct statement, that is finite rotations are vectors but infinitesimal rotations are not. Both finite and infinitesimal rotations are vectors. Third option is infinitesimal rotations are vectors but finite rotations are not. And the fourth option is neither finite nor infinitesimal rotation are vectors. So which one is correct? The third one is correct, right? That is infinitesimal rotations are vectors but finite rotations are not. Now the next problem is this one. This QPR is rotating also this about this shaft SR, and this SR is also rotating with an angular velocity of omega. So the first part of the problem is find out the magnitude of absolute instantaneous angular velocity. That we can find out, right? Omega, that is omega 1 plus omega 2, that is nothing but omega 1 is 2, omega 1 plus omega 2, omega 1 is 2i and omega 2 is minus of 1.5i, that is in the negative y direction, right? So that gives omega equal to 2i minus 1.5j. So the magnitude of omega is square root of 2 square plus 1.5 square, that is equal to 2.5 radian per second. Now in the next part we are asked to find out the magnitude of absolute instantaneous angular velocity. Now first we find out, we find out alpha, that is nothing but minus 1.5j cross 2i, which is equal to 3k. And we can easily see that the magnitude is nothing but 3 only, that is 3 radian per second square. Now what we are asked to find is the x component of v. Now for finding out v, we first need to know r. R is nothing but 0i plus 1.2j and 0.8 plus 0.8k. So it can this can be seen from the figure itself. You can very well see this. So I know r, I know omega, so I can calculate v, right? So that is nothing but the cross product of omega and r. So I just calculated this and I found out this v to be minus 1.2x minus 1.2i minus 1.6j plus 2.4k. So the x component, as you can see from here, it's nothing but minus 1.2 and the y component is minus 1.6 and the z component is 2.4. And in the next problem, a crane is operating at the site constantly, rotates at 1 radian per second about its vertical as shown. So delta dot is given as 1 radian per second, so it is rotating about this y-axis. And the boom of the crane supporting a weight is being lowered with an angular velocity and angular acceleration as shown. Now we need to calculate several questions related to this. So beta is given as 65 degree and beta dot is given as, that is the angular velocity, is given as 0.5 and the angular acceleration is given as 0.2 radian per second square. So what is the magnitude of the instantaneous angular velocity? It's nothing but minus 1j. You can see it from the figure, right? Delta dot is 1 radian, so that will be minus 1j and minus 0.5 minus 0.5 k. So for finding out the magnitude, we just need to do like that is square root of 1 square plus 0.5 square, which is nothing but 1.12. Now next part of the problem, what is the magnitude of the instantaneous angular acceleration of the boom? It's not the first, we need to find out alpha 1, that is minus 1j cross minus 0.5 k, which gives 0.5 I. Now to find out the total instantaneous acceleration, there is another component of 0.2, right? That is the beta double dot, and this is with a negative sign. So this is the total acceleration, and now I have to find out the magnitude, which is nothing but square root of 0.5 square plus 0.2 square, that is equal to 0.54. Now they have asked to find out the instantaneous velocity of the tip of the boom. Similarly, like the other problem, we first need to find out the position vector of P, Rp. We saw from the figure that it is nothing but 25 cos 65 I plus 25 sin 65j plus 0, because there is no z component. Now Vp is nothing but omega cross r. I just substitute the values and get Vp as this 11.33 I minus 5.28 j plus 10.56 k. So this is from here I can conclude that x component is 11.33, the y component is minus 5.28 and the z component is 10.56. Now the next part of the problem, we are asked to find out AP. So we just write the formula for AP, that is alpha cross r plus omega cross v. I just substituted all the values and then separately solved for part 1 and part 2 and added these parts together. So this gives AP. So the x component of AP is found out to be minus 8.67, y component is minus 7.77 and the z component is 22.66. So these are the components of AP. Okay, so this problem is over. Now the last problem is of the cannon barrel, which we just now solved, with which is rotating with an angular velocity of omega 2 equal to 1.5 radian per second, and it's placed on a platform which itself is rotating with the angular velocity of omega 1. And these are the details that is given for this problem. Now we are asked to find out the angular, let omega represent the absolute instantaneous angular velocity of the cannon. So we need to find out omega. So omega is nothing but minus 1.5, omega 2 is minus 1.5 I, right? Yeah, omega 2 is 1.5, but it is in the negative direction, so that is with a minus sign. Similarly, omega 1 is 3.5, but that is also in the negative y direction, So that is with a minus sign. So the x component is nothing but 1.5. The y component is minus 3.5, and the z component is nothing but 0. So these are the problems that we solved for this week. So we will stop here.